Okay, Assalamualaikum and hello. So we continue our topic with transformer. For topic 2 we start with the magnetism. Okay, so this one is 2A. Now we focus on 2B, which is electrical circuit. Transformer. Okay. So we start here. So you can see here the notes available. You have the textbook here, which is from Huge. Okay. So you can use the textbook to understand the topic, or you can use the slide. Okay, so this is the slide. This is an extra note. So this is the main note. Just this. Okay, so you can see here, this is the note. Okay, so topic 2 part 2 transformer. Okay, we will start with the two winding transformer construction, equivalent circuit. Okay, equivalent circuit parameter, voltage regulation efficiency, auto transformer, and three-phase transformer. So you can see here, this is the figure for transformer. Okay, so this is basically a distribution very large voltage. Okay, transformer. You can see here, this is if not mistaken, this is a three-phase transformer. Or you can see here, this is a the large one is the 50 Hz transformer. Okay, and the small one is the high frequency transformer. So basically your phone charger use this type of transformer, a very small one. Okay, so this is another figure of transformer. So this is a high voltage transformer. Okay, this is a three-phase transformer, and this is a 50 Hz small transformer. Okay, this is a small power transformer. Okay, so the word transformer means that electromagnetic device that transform electrical power from one end to another at different voltage and different current at same frequency. So what is that means that, so you have a, okay, so example, this is 100 volt, okay, 1 ampere. So you have a transformer here, TX. Usually we use TX to represent transformer. Okay, and this is 50 Hz. Okay, so after the transformer, sometimes you can change this into 1 volt, 100 ampere, but maintain 50 Hz. Okay, so basically you can change the voltage and the current using transformer. Okay, but make sure that P in is equal to P out. Okay, this is the law, right? Power input is equal to power output. This is for ideal. For non-ideal, P out will be lower. Okay, so something like that. So basically your voltage and current change, but the frequency doesn't change. Unlike motor and generator, it is a static machine with different turn ratio and primary and secondary winding through which voltage and current change. So for this part, you can see here, transformer doesn't have moving part. It's a fixed static device. Okay, for motor and generator you have spinning part, but for transformer you don't have spinning part. The transfer of energy takes place through the magnetic field, and all current and voltage are AC. So for this case, okay, for this explanation, okay, let me show it. Okay, transfer energy, you can see here, this is electrical V and I. Okay, and then in the transformer TX you have the magnetic energy. Okay, and then you change back to voltage and current. So electrical, magnetic, and then electrical back. Okay, that is meant by this sentence. Okay, and this one needs to be AC. You cannot use DC for transformer. Okay, it doesn't work. Okay, make sure you know this, only AC. And the rating for transformer is either in kVA or MVA, because of the load connected is unknown. So basically, if you want to know the size of the transformer, you look at the S. Okay, S is apparent power. Okay, don't be confused with reluctant because you just learned about reluctant. Use the same symbol, but for this case it is apparent power, so the unit is VA. But for transformer we usually use kVA or MVA. kVA is much more smaller. Okay, so transformer are adapted to numerous engineering applications in many applications. Okay, so power level from fraction of voltage ampere over thousand of milli voltage ampere. So power level, and then application for power supply, impedance matching, circuit isolation, for frequency range, power audio, voltage classes, okay, cooling type, and distribution rectification, furnace, and etc. So you can try to memorize this. Okay, so this is the application of transformer. So example of transformer classification. So this is the classification of transformer. You have three-phase transformer step up. So there are step up and you have step down transformer. So what is this mean? That for step up and step down, okay, you look at the voltage. Okay, you look at the voltage. For the step up, V in is smaller than V out. So basically voltage is increased. Okay, step down, V in is larger than V out. So basically the voltage is reduced. So that is how you differentiate between step up and step down transformer. So make sure you know the term. Okay, step up transformer are usually from generator to transmission. So if you recall back your system, you have generation, okay, transmission, and distribution. Okay, so you have a system here, you have a system here, you have a system here. So for generation to transmission, you use step up transformer. Okay, okay, when this one is usually kV, okay, 22 kV. Okay, this one depends on the generator. Okay, you have to step S up, either 132, 2575, I think, and 500 k volt. Okay, so you step up the voltage, and then during distribution you cannot use this voltage, you use step down. Okay, so for this case is 33 kV, 22 kV. This one is on Johor only, 11 kV. Okay, 415 kV, 415 V or 230 V. Okay, so this distribution is used step down transformer. Okay, so make sure you understand this. And you have instrument transformer, voltage transformer, or current transformer is used for measurement and practical. So basically you also have the transformer that used for measurement. Okay, for example, you have a circuit here. Okay, you have a circuit. Okay, this is a power supply. Okay, maybe I clear this first. Okay, you have a power supply here, you have something like this, you have load. Okay, so you put a transformer here. Okay, you put here to measure. Okay, this is it's called a instrument transformer. Basically it doesn't carry any power, but it's used for measurement only. Okay, why? Because measurement usually involve around a small voltage. Okay, this one is large voltage, so you have to reduce the voltage to measure the system. Okay, you have auto transformer used for measurement, practical, and supply utilization, and isolated transformer. This one is more towards safety. Okay, this one usually have ratio 1 to 1. It doesn't step up, it doesn't step down. Okay, it's just for safety. Okay, because it is isolated from the input and the output. Okay, because of the transformer you can use, we use a AC system. Okay, because we can change the voltage easily using transformer. Okay, so function of transformer, this one also usually asked in the theory: rising and lower the voltage or current in AC circuit, isolated the circuit, enable the transmission of power, which last distance. Okay, this one also another function of transformer. Okay, provide electrical power according to utilization need. So make sure you memorize this. Okay, of course this is the system. Okay, you have the power plant, grid. Okay, you have the transmission line, you have the step down transformer before it goes into the industry, commercial and residential. Okay, sometimes you have multiple step down transformer. Okay, for example this one is maybe 32. Okay, some industry use 32. Okay, some needs 415, some needs 230 volt. Okay, so typical power system consists of generation, transmission and distribution. Okay, this one I already explained. A power plant station generate around 11, 13, 20 to 30 kV depending on manufacturer. This one also I already explained. Okay, generation voltage usually varies around kilovolt. The voltage carried out at a distance to reach utilization transmission line by step up transformer at different voltage level depending on the distance loss. So what does this mean that? So remember that I say this is generation. Okay, so you step up. Okay, so this is transmission. Okay, so remember power is equals to I squared, power loss equals to I squared R. Okay, R is the resistance of the wire, I is the current. So basically the relationship is, okay, power loss, this one is current. Basically the higher the current, the higher the losses. So for this to work, you have to reduce the current, but you cannot reduce the current directly. Okay, because you reduce the current, you reduce the power. So you have to increase the voltage and reduce the power, because P is equals to VI. Okay, so if for example this one is 10 kilovolt, this is 1 ampere. This is just example, usually this is higher. So we step it up basically. Okay, sorry. So this one cannot delete. Okay, for example this 10 kilo, maybe 10 ampere. Okay, for example 10 ampere. So when you step it up, step up transformer, you have put a transformer here. So at the transmission line, you can reduce the increase the voltage to 100 kilovolt, but the current become 1 ampere. So basically you reduce the current, you reduce the power loss. Okay, but the voltage is very high, you cannot use it in transmission and at distribution. So at distribution you reduce it, the voltage back to a much more lower part. So for example here 100 ampere, okay, and 1 kilovolt, something like that. Okay, so this voltage carry out at a distance to reach a utilization transmission line system by step up the transformer at different voltage level depending on the distance and losses. This one I already explained. So basically you just want to reduce the current so you can transmit the power further. Okay, its distribution is made out of step down transformer according to the customer demand. This one also I already explained. Okay, here again at this stage the transformer play an important role to reduce the voltage and suit the customer need. So basically you can see here you have multiple step down transformer depending on the customer. Okay, so industry usually have want a higher voltage, commercial also a bit higher, but the residential usually at a very low voltage. Okay, this is a standard transmission power transmission for Malaysia. You can see here the AC generation is around 30 kilovolt, and then the transmission is around 500 kilovolt, very high. Okay, so at distribution it will be reduced. So for this one I think it's not in Malaysia, this one is I think in US. So different country use different voltage level. Okay, transformer is a device made up of use of magnetic coil couple to transfer energy. So what is this means that you have a magnetic coil, something like this. Okay, and then you have winding here and then you have winding here. So what is this mean? A transformer divider make us magnetic coupled coil to transfer energy. Typically consists of one primary winding coil and one a secondary. So usually at the left side is the primary and right side is secondary. So make sure you use the same standard, primary and secondary. Okay, and the primary winding, the circuit is called the primary side. So this is primary winding, this is the primary side. So this is primary side, this is secondary side. Okay, so magnetic circuit provide the link between the primary and secondary side. So magnetic circuit basically this one. So I already explained before, this is electrical circuit, and then this is a magnetic circuit, then electrical circuit. So this is the standard drawing for the transformer. So you can see here supply is set at the primary winding and the secondary winding this goes to the load. Okay, so make sure you understand it. Supply at primary, okay, load at secondary. Okay, so IP is okay when AC VP is applied to the primary winding of the transformer AC circuit, IP will AC current IP will resolve. So you can see here this one you put a supply, okay, primary always supply, and then you produce I primary, and then time varying, okay, it will produce flux. So recall back, this is, so maybe draw this is flux. Okay, in the magnetic circuit you produce flux, and then at the secondary side it will produce I secondary, okay, IS, okay, and also VS, okay, plus minus VS. Okay, I think we still have time. Construction, okay, so you can see here the construction of magnetic iron core is made of laminated shield. Okay, remember eddy current, that's why we use a laminated shield, laminated steel sheet, okay, to minimize the eddy current loss and reduce thickness. Okay, so you can either use a square cross section or round cross section, okay, circular cross section. So make sure you know the type of cross section, okay, square, rectangular, or circle, or step. Okay, so usually for small transformer we use square, and for a large transformer for a 3-phase system we use circular. Okay, and another type, another thing is core type. Okay, so you have a UI core type and shell type. So what is the difference? Wait, let me check. Okay, maybe I should draw this. Okay, okay, UI means that you have U and I transformer. Okay, so basically you do the winding here, you do the winding here. So this is something like this. Okay, this is UI, and another one is shell type. Okay, and you have this one. Okay, you do the winding at the center usually. Okay, so make sure you know the type of the core, either UI or shell type. So this is primary and second winding are winded at different leg. Okay, for shell type it is primary and secondary winding are wound at the same leg at the core. Okay, so basically this one you wind the primary winding here as well as secondary winding at the same side. Okay, so this is the figure. Okay, this is the cross section of the core. So this is the L shape laminate. Okay, this is E shape lamination. Okay, this is the, okay, this is one way to laminate it, to wind the transformer. Okay, this is the shell type. Okay, you can see here the primary winding and the secondary winding is at the same side. Okay, so I think that's it for today. So next class we will learn about the ideal transformer, the calculation of an ideal transformer. Okay, so that's it for today. But don't forget to sign in your attendance and make sure you know that the test will be conducted at 29 November. So I repeat back, the test will be conducted at 29 November. So make sure you prepare, and the title for the content for the test one is available in e-learning. Okay.